Okay, in the last couple of videos, we've been dealing with solving systems of equations by graphing the lines. But what if it's impractical to do that? Or what if it's just too much of a pain for us to actually do that? Do we have any algebraic methods of doing this? And the answer to that, of course, is yes, we do. It's called a system of equations, solving the system by method of substitution. Now, on page 267 of your textbook, it says solving a system of equations by graphing is based on approximating the coordinates of the point of intersection. However, what if that point isn't a nice even 2, -3, or something like that, right? What do? Well, an algebraic method called the substitution method can be used to find the exact solution of a system of equations. And to use the substitution method, we must write one of the equations of the system in terms of x or in terms of y. Right? So our answer right here is that we say that to solve a system of linear equation by substitution, we're going to solve one of the equations in terms of x or in terms of y, and then replace that variable in the other equation with the variable expression you found in the first step. Well, I'll call your attention to this bottom one right here. We're actually going to use the substitution method to solve this one. And it does kind of scream out for something right here, right? You'll notice that in this first equation, x is in terms of y, right? What this means is that the x variable is isolated to one side of the equation and everything else is written as an expression that involves y. So how is that useful? Well, it says replace the variable in the other expression with the variable expression you found in the first step. So what we're going to do is that everywhere we see x in the first equation, we're going to replace x in equation 2. So in the equation x plus y equals 5 with the expression negative 2y plus 12. So let's carry that out. Let's see what that means. So we have x plus y equals 5, replace x. So everywhere we see x, in this case, x plus y, so we're going to make it negative 2x plus 12 in place of x plus y is equal to 5. And I made a mistake there. That's not negative 2x, that's negative 2y. Oops, negative 2y, right? We said that x was equal to negative 2y plus 12. So here it is. That's what x is, right? All we're doing is we're just replacing it. So now we've got a perfectly nice equation that we can solve in terms of y, right? If we just drop the parentheses, at least in this case, negative 2y plus 12 plus y will equal 5. Now let's see, let's simplify this. Negative 2y plus y is the same thing as negative 1y, right, or just negative y. So we've actually got negative 12 minus, or 12, positive 12 minus y is equal to 5. Let's isolate y by subtracting 12 from both sides. Subtract 12 from both sides, and so we get negative y is equal to negative 7. Of course, to get y by itself, we divide by negative 1. We find that y is equal to positive 7 is the value. But we're not done. Remember, we need to find, if we're solving a system of equations, the x, y coordinate pair. But we know from the first equation that x is negative 2 times whatever the y value is, plus 12. So if we do that, make that substitution for y right here, we're going to get negative 2 times 7 plus 12 to get our x value. So that's x is equal to negative 14 plus 12, which is to say that x is equal to negative 2. So if we were to substitute into the equation right here, if we were to draw our two graphs, we would find that they would meet at the coordinate point where x is equal to negative 2 and where y is equal to 7. So our solution is expressed as the ordered pair negative 2, 7. Another example in the next video.